I assume so. So kind of nice to talk after this GDS presentation. I'm continuing with some security related topics, so touching the GDS a little bit here as well in my presentation, but what I want to concentrate on is role-based security management for industrial devices and applications based on OPC UA. And you will figure it out later what that means in practice. So first, Stefan was asking where are we? So we are located in Espoo, Finland. It's next to the capital. ProsysOPC is celebrating 30 years of existence just in a couple of weeks in practice. And we become a global expert, especially in OPC technology. We started using it right from the beginning almost, and have been able to produce tools for the industry. And we've been an active member at the OPC Foundation for almost 30 years as well. If you used OPC in the past, you're probably familiar with our simulation server and browser, which are developed with our SDK for Java, which is our main tool that we've been developing for almost 20 years. And we also try to bring more useful products to the market for the end users. And as said, I've been working here as a CTO almost since the beginning, so I'm in charge of the technology, but we have a team of good developers, and also been working together with Stefan at the OPC Foundation, arranging the events and speaking in the world, and also at the Finnish Society of Automation, and also at IEC and ISP. But to the topic of the day, so we're talking about OPC UA, which is a standard, and the standard defines different topics for communicating communicating industrial data with different systems. The information models is the most fancy part, and we'll hear more about those later this week. But security is the main topic of today. And if you look at the specifications, the security is defined in several parts, and the main topics relate to even encrypting all the data to ensure that nobody can steal the data, and also to authenticate applications and users. And for user authentication, there's different ways to do that. And with that information, you can do access control. And OPC also defines in part 18 how you do it role-based. And another topic of security is the audit logs. If we look at more closely about OPC UA security, so it's based on all the applications getting an application instance certificate, which is used to authenticate, kind of identify these applications. And with OPC UA, you can even go down to the device level and authenticate those and have security all down there, which is not possible without any other technology, or with other technology. And also on top of that, you can have different users and different user identities, and then choose different functionality based on those users. But to help with giving the permissions, it's easier with different roles instead of just direct user identities. So access control is based on identifying people and applications. And trust list is the way how in OPC UA each application then decides who can connect, and then the permissions define what can you do when you being able to connect with your identity. So identities are used to authenticate users and applications. And then the servers define which identities may perform which operations, like connect, read, write, and so on. And this makes the permissions. Now, if we look at the role-based access control, so administrators define permissions for roles instead of identities. the idea is that then users or identities get the roles, and based on those roles, they get the permissions instead of directly. For example, if we would have a user called Alice, she could get observer role, and the observer role brings her the permissions to browse, read, subscribe, history read. These are OPC UA operations in OPC UA servers. And the target is to have better change management. It's easier to remove people from the roles instead of trying to find all the access that they have to different applications and which permissions they have here and there. So that's the main target, that the management of the security is better, and that then creates more reliable security in general. OPC UA defines standard roles, so well-known roles that can be used in the server. So we have observers, operators, and the specification already kind of gives definitions what kind of access these different roles should have in the servers. But there are still some open questions, and Lucas, my colleague, was making his master's thesis, just finishing it at the moment, or it's been not 100% published yet, but it's there. He had a few questions that he was trying to work on his thesis. I don't really have time to go into the answers deeply in this presentation, but the main topics were that where should the identity role permission be persisted? It can be local in the applications, or it can be central in the OT networks. It could be central in the IT network. And this is still like, there are different options. And especially if it's not locally stored, then how is the operational availability ensured that the applications always can access this information? And of course, the most important question, how are the roles made as useful as possible in practice? Like what kind of roles and how do you deal with those in a large network? So although the principles are quite simple, but in the practice is maybe still always not that simple. But you can check out his master's thesis when it comes out. In OPC UA, we have the idea of central security management, and this is based on the GDS that we heard the previous talk from Fabian. And the Global Discovery Server is an application that's supposed to manage the application instance certificates of every OPC UA server and client. And on top of that, it can also manage users defined in these applications and roles. And then the idea is that each application can then decide on the permissions on their own, but they get this mapping to the roles from the GDS, and that's kept up to date. So the administrator makes changes centrally in the GDS, and that gets spread out to the whole network. And then the GDS also like updates the trust lists to the server. So this is the information about which applications can they trust on. The idea with the central GDS is that everybody who gets their certificate from the GDS is basically trusted in the network. But if you need to revoke someone, take off some application or some user, you need to transfer that information to the application so that they are up to date with these changes all the time. So that's the role of the GDS. But as you heard from the previous presentation, we may be not quite ready for this yet. So first of all, this requires GDS support from all applications. And unfortunately, it's still true that the SDKs are not all 100% ready for this, and the applications therefore don't all have this functionality yet. We have the GDS products now available in the market, but we still need to work on the applications to get this support. So this is still more in future solution, but that's the target where we are going. Meanwhile, the alternative that we want to suggest, and maybe this can be actually an overall improvement to the architecture of this communication network is the aggregation server. We already heard something about aggregation servers yesterday, about the idea, but here the main reason for aggregation server could be that it's enabling this IT-OT integration by giving a single point of access from the IT network to the OT network. And it should sit in a DMZ area where it's like safe from enabling access directly from the IT to the OT. So this is like a demilitarized zone in between. The outsiders need to get first to this DMZ area before they can try to get to the OT network. And this gives additional security in general. But of course, we still need to keep the firewalls between and limit the access to the aggregation server only from the IT, and from the aggregation server you can limit access only to the underlying OT with OPC UA, for example, and therefore it can be very safe. And then if you also require OPC UA security in all communication, you should be really, really safe with this architecture in general. So the aggregation server can also act as a security gateway in between these networks. And therefore it can also or needs to know about the application identities to identify both the IT applications and the OT applications that it connects to. It can use user identities, and you can define roles in the aggregation server. These roles can be defined locally in the server itself, or it could have the integration to the external Active Directory or LDAP system where this is maintained. And this is one of the open questions, that can we kind of integrate into the IT administration that is handling users, for example, in this LDAP or Active Directory registries, and also the user information in there, or do the OT people want to have their own system, or where are these roles and user identities, application identities, like handled in central fashion, or is it distributed? It could still be like a few different systems, but these are still like the alternatives here. Anyways, based on these users and their roles, then we can decide on the access control in the aggregation server, which means permissions in general. And to demonstrate this a little bit, we have an application for this purpose called OPC UA Forge. It's an edge application, and the main idea and the main architecture here is that it's an OPC UA server in the core. So everything is based on OPC UA in the first place. There's a variety of different south and northbound connectivity, so it can convert between different communication alternatives. But it also has the security configuration within it, so you can use it as a secure gateway between networks. And here is an example. In Forge, you can define global permissions. For example, disable everything by default from all the users. And on the next level, you can define user groups. And I will define now an observer group. Here we don't really talk about roles, so we talk about user groups, but the user group is kind of a role already. And then we've overridden the permissions, so this observer can now browse, read history, read role permissions, and receive events from this OPC UA server. And then Alice could be part of the observer group, and with the observer group, she gets these permissions given by the group. And if necessary, we could of course override some permissions for Alice here specifically, but of course it's better if she just keeps the permissions from the role. Okay, and then we can continue the thinking IEC 62443 talks about zones and conduits, where the idea is that we should separate, even the OT network should be separated to smaller networks so that it's not like a big area where if you get access in there, you get access to everything. And the conduits define that we can connect or communicate between the networks in a managed way. And in this architecture, we would install one forge per network who's responsible of communication within those networks, and then they would be connected with each other. And if we think about this even further, we could say that you could force all the communication to go through forge, so that within the network, everything needs to connect through forge, and then you can administrate everything centrally there. You don't need to like decide on each and every application who can connect to which one. And of course, between the networks, all the communication should then go through the forge instances only. So this is like a second level of security that we want to talk about. I'm not saying this is necessarily the best architecture, but it might be. And then the next stage is that how does a GDS come into the play? Would the GDS still be there sitting in the IT network, for example, or somewhere else, and be administering the identities with forge, so that would be outside forge? Or should there be a separate GDS in every forge application, so that the local networks are managed with the local GDS installations as well, and then they are connected with each other? And I think this kind of architecture where the GDS is not just one instance but several instances is also in the spirit of OPC UA in practice. So without going more into the details in this presentation, I want to thank you, and you can always contact us to ask for more details and maybe even a demonstration live. So thank you for that.